Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 79. So I just got finished recording the previous one, so now we're going to do it again. But this time we're going to work on extending the functionality a little more. So we're going to begin here with this handle update score. So this is the last of the functionality of the not implemented the major features of it. There's still a bunch of cleanup we need to do, but we'll go ahead and get the last of the features in place. So I thought about how I want to tackle this. So what I think I'm just going to do is well, this side's easy. This we're just going to do leaderboard manager dot update score, and we'll pass in player and points. So we'll use so for points, I think we're going to use a positive number for addition, negative for subtraction. We'll just do something like that. So let's start here. So we need an ID. So we'll start with our header, CW. Generate header. Update player score. Alright, so now the first thing we need to do is we need to get the player ID. So the easy way is just to ask for an ID. I think the better option may be to do what we did up here for find player. So what I'm imagining is search by ID instead of returning show by player. Let's have it return the player. Same thing here with search by name. So now we'll have them return the player, and then we'll show the search results here. So both of these will have a player. So now here we will return player, and here we will return player. I think that's more what I want to do. So now we will do our search. So let's see, how do we do it up here? Let's do this. Let's do handle find player here. Pull that out to a private method. Private static player find player. Search for player. I don't think I need anything. I think it's self-contained. Then we return player. It doesn't need something, it needs the leaderboard manager. Player equals search for player, passing in the leaderboard manager. So now we handle that functionality there. We abstracted out a little bit of the logic though, so we can do it down here. So we will do player equals search for player, passing in the leaderboard manager. So now we've got the player.id, and then we'll get a points. So int score equals get user input, enter score negative. Negative reduce score. Something like that, maybe. And now we will pass in score. So there's a problem here, though. What if player doesn't exist? So if player is null, CW player not found, return. Maybe something like that. So I think that gets us our update scores up to this point. So now let's see what happens to the score here. Maybe should that return anything? It doesn't right now. I'm thinking maybe that should just return the player, and then we could just display it. So maybe something like player equals this, and then player dot CW player was updated to player score was updated. Player let's do this. Let's do player dot we don't have this method yet. Let's do display identity maybe. I think I misspelled that. I'm trying to think how I want to do that. Something like that. Players score was updated from player dot score to player dot score, but that's not going to work. So here, we got it here actually. No. I guess we'll do it like this. Int original score equals player dot score. And we'll do it like that. So player identity. Let's go check this class out. I think it was a record as well. So we will have a public string get identity. Maybe that's what I wanted to say. Get identity. All right, so this, I'm imagining we'll do, let's do something like this. And it's going to be this to do actually. So we will just do a return. what I'm thinking of is return name. Let's do it ID name. Maybe like that. Alright, no, it's not like here. Oh, yeah. Update score and it returns the player. I don't think it would return a null player. Yeah, I think that makes sense. Let's just call this updated player. Can it just be player? Wait a minute. Yeah, I think it can tell here that it's no longer null. Yeah. Okay, that should work. So now, save this, and let's go over here. So now we need to actually do the method here. So we're going to find the player ID and update them. So for the dictionary, that's not hard. So player equals find player, passing in that ID. So if player is not null, here, let's do it the other way, is null, throw new argument. It's not argument. Throw new invalid operation exception maybe. Player ID, player with player ID was not found. Alright, so if that happens, we're done. Otherwise the player was found, so now the player's not null. So now we can do this. So now we can do can we just update it? Wait a minute. Just do plus equals points. Is that actually updated? I think it shouldn't, right? Return player. Yeah, I think this won't work, but let's check. Yeah, because I have another plan, but if this works, then my plan failed. 1. So now update score. Search by ID, yes, 1. Update to 42. So now if we show the top player, it was updated. Let's add another player. Let's do exit. Let's generate. We'll generate 100 players. All right, now let's do update, and we'll update player. Yes, we'll do 98. I should do current score. No, let's not do that. That makes me want to enter the final score. So 98 has 490. Let's do negative 10. Okay, yeah, I think that works. Let's do let's do show rankings. We're looking for player 98. That looks like it may have actually worked. Which may make sense since it's a reference type and we're adding it everywhere. So what I was thinking was that we would need to do some more work here. So what I was thinking is instead of doing this, we would find the player, update it here, then go find it in the tree and update the tree. Yeah, we still need to do that. Okay, so that worked, but if the position changed in the tree, like if there was two that were about the same place and that changed where it should be in the tree, it doesn't update. That's what I was thinking of. So we do still need to do that. So how I was thinking to address that would be just to take the player and do something like this. So we have what was it? Tree dot remove dot delete player tree dot insert player. Same thing with heap. They're not called heap. Max heap dot remove player. There we go. Player.id max heap dot insert player. That's what I was thinking I would need to do, and I think I do need to do that. So what this does is it takes it, removes them from both the heap and tree, and adds them back. The reason we don't need to do that up here for the dictionary is that it already sort of supports that. So what we could do here is we've grabbed the player, yeah, let's make sure that works, but I think it does. So generate players, 100. All right, so 98 got 471 this time, so about the same score. 3, update score, yes, 98, negative 200. So that'll definitely cause them to drop positions. So now let's find the player. Yes, 98. There, if we show rankings, 271 looks about where I would expect. So the top 55 places. Is that all right to show rankings? Wait a minute. $75, wait a minute. Did I completely misread that earlier? must have misread that at first. So now I think they do line up, I believe. Yeah. Okay, I believe that does line up. Okay. So that'd be a good thing to actually have a test here for and check that. So we might do that eventually as well. No, check can be simplified. How can it be simplified? Okay, we can do that. But there's our update score, and I think that's pretty. I think that should work. So a little bit of extra work there. So let's look at one of our to-dos here. Not this one. Where did I have a to-do? Here, maybe it's in here. Yeah, here we go. We can be more efficient to not copy this. So I was thinking about this one. So with the heap operation, we're using this to get the top so many people. We have a tree already, and it's already accustomed to this, so maybe we should rethink how we do this. So the heap's really good at getting the top player. So let's go over here. So let's make this, this is going to be a little bit more artificial, but so if number of players to display equals 1, return max heap dot peak. So else, so there we make use of the heap to do a really efficient peak. So who's the top player? We could do that with the tree though, just grabbing the root since it's sorted that direction. We're going to keep the heap just because I wanted to use the heap, and that was in my original plan. How we're actually using the heap probably doesn't make sense. So what we can do instead though is we can do tree dot traverse in order. Or, list of players equals that, and then we could just grab the top so many. So we could do players dot number of players to display, maybe something to that effect. It's not hardly the right syntax, is it? I was going to try to do this that way. What I was actually going to, how I was going to program it though, was going to go over here and do a traverse in order. And I was going to just have a method that only does however many it needs. Let's make the other one work. So the other one's more efficient if we only do however many we need, but I think it'd be harder to keep track of. So instead, let's make this work. So there's our list. So list players, return value equals new list for int I equals 0, I less than number of players to display, I plus plus. So return value dot add players at I, and then we can return, but that's not efficient either. Well, I guess that is efficient, but it's as efficient as we're getting here, but there should be a way to do that built in. So we should be able to slice the players here. Players dot which one am I thinking of? I actually don't know which one I'm thinking of. Maybe sequence mini would do. We could just do take. Yeah, never mind. Take number of players to display. And then we gotta do a to list. I think something like that would work. Let's see if there wasn't a better one. Yeah, there we go. Okay, that would probably work. And then we don't need a return value nonsense here. Let's C# handle it instead of us. That probably makes sense. So let's see if that works first before we say it makes sense, but I think it does. Let's generate 100 players. Now let's take the top 10. I think those look like relievable top 10 scores. Let's update player. Let's update player 99. They have a score of 999. Now let's show the rankings. No, show top players, top 10. Now 99 should be at the top. They are. And I didn't do the scores right, but yeah. Okay, I believe that actually did what we wanted it to. So the consideration here, and I'll think about doing this in the future, but to do, maybe just stop the search when we have the count we want. So that'll be more efficient if we had a bunch of values. Right now, it's not going to take long to do 1,000. Maybe if that was a bigger number, maybe then it makes more sense to split that out. And then we could just say, just get the first, I don't know, first 10. And then once it adds 10 values, go ahead and stop. But that's going to cause us to need to do some, we're going to have to keep track of how many we've seen. That's going to be a little more work than what we're ready for, I think. But I think that's good for that functionality. Should use player instead of player ID. Yeah, I agree. Players.remove. Oh, that one's hard to do. Oh, I guess we could just do this though. Yeah, this one could just be player. And then we don't even need to do this. Rebuild, make sure that rebuilds. Is not good. All right, now I think it will rebuild. There's 2 more to-dos. There. Okay. Yeah, there's 2 more to-dos out of the way. I'm not going to touch that top one yet. I'm not going to do that one. Let's see what other to-dos we had left. We have lost our task list. Let's grab our task list back and let's take a look. Line up the headers. Yeah, get top players is no longer needed. We can remove that. We can remove that one because it's not used either. I'm going to keep that one because that's the actual heap operation. We can remove that. We can make this be this and remove a little bit more code. And then we don't need this as well. All right, let's make sure we build. Good. Okay, what other issues were there? We spelled retrieve here. Now we can do that now, can't we? That one's tricky. We could do that. Here, let's consider this one. So what we could do here is we, instead of returning bool here, we could return the player that was removed. That way, if the player removes null, we're just done. I think we do. I think we do. I think I do make this change. So let's make this player. So now we return null here, or we return player to remove here. Everything else stays the same. So then we, over here where we use it, this is now wrong. So now we do player if player is not null, then we can do that. Oops. And here we'll just do player dot get identity, and we'll display it like that. think that'll make it a little nicer on us actually deleting. So let's test that. So remove a player. Player was removed, successfully removed. So let's do this again. 1, 1, 1. Remove player 1. I might want to flip them. Have the ID in parentheses actually. Let's see where else we use it, but I may want to flip those. So player. Yeah, let's do that. And then we can flip the identity, so we'll do that. So let's make this one the name. ID equals ID. Maybe that, let's see how that looks. 1, 1, 1, 4, 1. Instead of that, let's do make it a little shorter. But I think I like that actually. I think that'll actually work better. So update score. No. Player name. We'll bump it up to 42. I think I want that to say player 1 at a score. So just drop the S altogether. Let's adjust that. Player 1 score was updated. I think that reads close enough to readable. So we'll make that change as well. I didn't have time to do this one in between the 20 minutes or in between them two lessons, so I'm going to skip that one. I'm going to skip that one for testing. We'll be coming back to that soon. Consider overriding this so we don't have to do scores. Still an idea. I haven't 100% decided on that though. We can combine the logic. We aren't using remove max. That's one of the heap operations, but we aren't using it. Let's just remove it. If we needed it, it's not that complicated. We can add it back. So there's us another to do. Okay. Well, maybe a little short lesson, but it may be time to start considering looking at some of these harder to-dos to consider. And I say harder, this one's not going to be that hard. So there, we don't actually care what the result is of the remove there. The delete doesn't even give us a value, so we're good. Yeah. So now we're at the place where I think next time, rather than cleaning up here, we're going to begin testing some of this. So we'll add some unit testing around some of the functionality and see what we can get into with that. So as part of that, I have a feeling that our handlers are going to change. So like this get generate header, generate get user input. I have a feeling I'm going to want to do those a little differently, but I'll think more about that and come to a conclusion next time. So this has been episode 79 with programming with Shadow, and this one we finished the main functionality and did a little more cleanup. So next time we'll start testing it, I believe. So we'll call it there. So thanks for watching and have a wonderful rest of your day.